parallel axis theorem of moment of inertia. We will consider an area A, a plane area A of a plane shape, of a general plane shape, and we will see what is parallel axis theorem of moment of inertia of that area. We will see the statement of the theorem and the proof of the theorem. First of all, we will write down the statement. The parallel axis theorem states that the moment of inertia of a plane area A about any axis which is parallel to the centroidal axis of the area is equal to the sum of moment of inertia of the area about its centroidal axis and the product of the area and the perpendicular distance between the two parallel axes. So if AB is a parallel axis which is parallel to the centroidal axis of an area, then IAB, which is the moment of inertia about AB, is equal to IG plus AH square, where IAB is the moment of inertia of that area about the parallel axis AB. IG is a centroidal moment of inertia about a centroidal axis which is parallel to AB, plus A into h square, where A is the area of the plane or shape and h is the perpendicular distance between the two axes. So IAB equal to IG plus AH square. Now let us see the proof, how we can prove it. Let us consider an area, a general shape. Its centroidal axes are this one at O. We consider a small area which is dA, and the distance to the centroidal axis to the centroid of this small area is y, and we will consider a parallel axis AB at a distance of h. Let this be y and this is h. So we consider a plane area, its total area is A, and we consider a small elemental area whose area is dA, at a distance of y from its centroid y in the vertical direction, and we consider AB a parallel axis which is parallel to the horizontal centroidal axis of the plane, which is at a distance of h. Now, moment of inertia of this area about AB. What will be the moment of inertia? Moment of inertia of any area about an axis is equal to the area multiplied by the distance 2 times. That means here the total distance is h plus y. H plus y. So, moment of inertia of this area about AB is IAB is equal to integral h plus y the whole square into dA. That will be the moment of inertia of this whole area about AB. Okay. Now, when we expand this, we will get IAB is equal to integral h square dA plus y square dA plus 2hy dA. I'll write it here. It will be equal to integral h square dA plus integral y square dA plus integral 2hy dA. Isn't it? So this will be equal to h square dA is integral h square dA is a into or h square into integral dA means a h square plus y square dA will be, what will be y square dA? Y square dA means it is the moment of inertia of the whole area about its centroidal axis. So this is y. So if you consider the vertical distances of all the elements of this area, it will be ig, or in this case we can consider it as ixx. Say one of the centroidal axis or moment of inertia of this area about one of its centroidal axis. We will generally say it is as ig, where g is the centroid. Ig plus 2a y bar, where y bar is the centroidal distance of that area. Okay, so here y bar will be 0 because we know that centroid y bar is equal to integral y dA divided by integral dA, because the equation is y bar is equal to a1 y1 plus a2 y2 plus a3 y3 plus etc. divided by a1 plus a2 plus a3 plus etc. This can be written as sum of area into the corresponding distance y. So that can be written in integral form like integral y dA by integral dA. Then integral dA will be a, so a y bar is equal to integral y dA. So here we have integral y dA H is also here. 2h into a y bar. Y bar. Here, as we consider the moment of inertia about its centroidal axis, y bar equal to 0. Therefore, IAB equal to IG plus a h square, since y bar equal to 0. So this is the proof of parallel axis theorem of moment of inertia for a plane area.